Okay, so the last thing that we're going to have to learn today is learning how to predict reactants or products. So something's going to be missing and you have to figure out what's going to go in that missing box. And it all depends on like what type of reaction it is, right? So for example, you see how this one right here, you starting with the sodium. So here, I'm going to color the sodium, and then it's mixing up with an iron 3 bromide, and then you have a sodium bromide on the right, and then you're missing something, okay? You know, because of conservation of mass, that whatever elements on the left, your reactants, has to show up on the right, which are your products. So if there's a sodium on the left, there has to be a sodium on the right, okay? Then also, if there's an iron on the left, then there must be an iron on the right. We're missing an iron, okay? So you know, I'm do a little bit of coloring here. I'm missing an iron. Okay, then if there is a bromine here, then it has to be a bromine over here. Okay, so you know that I have a sodium on the left and right. I have a bromine on the left and right. So what am I missing? A sodium. So you're going to look at your answer choices. So you're going to have answer choices. So down here, right, question number 1, which one makes the most amount of sense? Which one did we say we were missing? We are missing the pink one, which is iron. So iron is the correct choice. So I would put iron here, okay? Okay, at this point, you should know how to balance pretty well. So I'm just going to do this really quickly. I have 3 bromines I need on both sides. I also need 3 sodiums, and now it's balanced. Okay, so it's 3 blank, 3 blank. Now you need to know what type of reaction this is. So you take a close look and you're like, okay, I don't have one product in the end, so it's not synthesis. I don't start with one reactant, so it's not decomposition. It's not a Cho equation, so it's not combustion. So I'm down to single or double replacement. Single replacement, remember, has a single element on both sides. I have a single Na and a single Fe, so you know that this is single replacement. Okay. All right, so next, let's try a different example here. Number 2, you have a sodium again on the left. I have a sodium on the right, so I'm good to go. I have a hydroxide polyatomics. Remember, if there's 3 or more capital letters, you know that there's a polyatomic here. So I'm missing a hydroxide over here. So keeping that in mind. I then have a hydrogen on the left. So I'm missing a hydrogen on the right. I do have 3 capital letters here. So this is a polyatomic, right? SO4. Remember, you can find those polyatomics here if you're struggling. The SO4, the 4 will go inside the parentheses, right? This SO4 here is on both sides, so I'm pretty good. So what am I missing? I'm missing some H's and OH's, so I got to think about what answer choice would fit best in number 2. So number 2, I think, okay, which one has H's and OH's? This has an Na, so that's not that one. This one's missing H's, so this is my best answer. It's H2O. So I'm going to write H2O here. Okay. Now that you don't really have to know how to balance these, but if I were to do this really quick, this would be a 2, and then that should be it. Okay. Not that it's important to balance, but you do need to know the type. So you look at it very carefully and you're like, okay, this has a partner and this has a partner. And what happened to those partners? They swapped partners over here. So that means this is a double replacement reaction. Okay. Let's try this one, number 3. This one starts with a C, H, and O. And you're missing 2 things. You're like, ugh. And you look down here and you're like, it doesn't even give me answer choices. But then you recall, every time you see a Cho equation, you know immediately that this is combustion. And you're like, okay, well, what did my notes say? So let's recap your notes about combustion. A combustion reaction is always a Cho reaction that has always in the products carbon dioxide and water. So that's why it didn't give me answer choices, because I should already know that this is carbon dioxide and water. And it actually doesn't matter what order you put them in, water or carbon dioxide, but those are your 2 products, right? Just for funsies, if I were to balance this really quick, 4, 5, 6, then it should look like this. All right, let me do one more example down here. So let's see. You have a silver on the left and a silver on the right, so I'm good there. You see that there are 3 capital letters here, so there is a polyatomic here. So polyatomic NO3 is on both sides, so I'm good. And then I have a, let's see, a polyatomic here, right? So I am missing an SO4. So I'm missing an SO4, and what else am I missing here? I'm missing an AL, right? So I'm missing an AL and an SO4. So you know if you go down here, you have to choose between an AL and an SO4. Okay, so you're like ALAG, nope. ALSO4, ooh, yes, ALSO4, ooh, there's 2 of them. Like, what's happening? There are 2 ALSO4 options, and so which one is the correct one? You have to consult your periodic table. So let's look at our periodic table to help us find this answer. Okay, so if you recall your periodic table, it goes +1, +2, +3, and then there's a 4, and then it goes backwards like this, right? And so what are we looking for? We are looking for an aluminum. And aluminum, what color did I make aluminum here? I don't remember. But aluminum is here, right? Well, I'll pick a totally different color. Aluminum is here, which is what? +3. So I'm going to make a note to myself that aluminum is a +3. Then what? SO4 down here is a -2. So do you see how it's right there? SO4 is a -2. So you got to think, okay, how many of each do I need to make this work? So like, okay, I need another +3 and I need -2, -2, right? So how many aluminums do I need? I need 2 aluminums for every, how many SO4 sulfates do I need? I need 3 of them. So every 2 aluminums, I need 3 sulfates. Remember, you got to cancel out the charges. You're like, cancel out the charges? I know it's been a while, but you don't have a lot of these questions, but you got to cancel out the charges. So which one is the correct one? It's this one because I need 2 aluminums for every 3 sulfates. Okay, so it's Al2 SO4 3. So right here, you would write that it's Al2 SO4 3. Okay. The thing is, like, if you choose the right one, you can tell it's the right one because it's the only one that will balance out correctly, right? So like, for example, if I already gave you these numbers, sorry, I cut this one off, but this is ALNO3, 3, right? Like if I already gave you these numbers, like I put a 2 here, oh, that's not gonna work. So if I put a 2 here and a 6 here and a 3 here, right? If I gave you these numbers already, then the only one that actually balances out is this one, okay? Because the other one, if you put that answer here, and no matter what you do, it's not going to balance out. You're gonna keep getting the wrong number. So you can always check conservation of mass to make sure it works out. You're like, hey, I have 2 aluminums here, I have 3 sulfates here. Sometimes you do need to add a number here, but if there's a number here, then you know it's going to be the right one because you can multiply it out and count to make sure it's the right one. Okay, so this one is correct, and this does become a coefficient of 1. So if you look at it, these have a partner, this has a partner, this has a partner, and this also has a partner. They all have partners, so you know it's double replacement reaction. Okay, the last example, actually I'll do one more right here, like this, right? If you see this example, you have a P on the left, no P on the right. See, this is where your arrow is, so this is where you're going to make sure it's on both sides. I do have a bromine on the left and a bromine on my right. So what am I missing here? The letter P, right? So I'm not missing P and Br. I'm not missing a PO4. I'm just missing the letter P, right? So that's what I would put here, right? If you do this, then this should all balance out nice and neat. You see how you started with one and it broke apart. You started with just one big compound and it broke apart. You know that's decomposition because it broke apart, right? We'll do more practice in class.